We're going to look at two more common displays of data, paired data sets. So the first one being a scatter plot. Each data point corresponds to another data point. And so we use that as X and Y axis. So we're not really graphing frequency, but we're graphing relationships between one variable and another. Okay. So for example, each dot could represent a person, and one axis could represent their the number of AP courses they're taking, and the other axis could represent their GPA or something, okay? So two variables, and each data point represents one entity with both of those qualities. So they're still graphed in an ordered plane, but again, shows that relationship. A really, really common paired data set is the Fisher's iris data set. I actually worked a lot with this in my grad program because it was a nice data set that allowed for a lot of different analytical models. And what it does is it takes three different types of irises, flowers, and it classifies them using actually 4 classifiers. So it's actually in 4 dimension, but you can break it down and just pick any two classifiers: petal width, petal length, sepal width, and sepal length are the 4 different categories. So this chart here has taken 2 qualities of the flower, the width of the petal and the length of the petal, and has plotted them on a graph. Each dot represents a unique flower, okay? This person went out and measured just hundreds of flowers and then took down all this data. And so for, any given flower, you can look and see what was the petal width in millimeters, what was the petal length in millimeters for those 3 different species of iris. When we do scatter plots, we're looking for trends, okay? And as with scatter plots, it's usually as one feature increases or decreases, what happens to the other one. So when we look at petal length, as our petal length gets longer, what happens to our petal width? It gets wider, okay? So as petal length goes up, petal width also goes up because we see this positive correlation. All these values are kind of clustered together, okay? We could also have negative trends where clusters, values are kind of clustered together in a downward pattern. If we have a scatter plot that's just kind of all over the place, then there's not really any trend to, as one value increases or decreases, what does the other one do? And so scatter plots give us that idea of any of that correlation between features within a data set. Last thing is time series data. Time series is composed of quantitative entries taken at regular intervals over a period of time. Okay? And that's to show change over time. All right? There are a couple typos in here. Yours might vary a little bit differently, I think, here. So I would fix that on your screen, on your paper. Very, very common time series data is like temperature readings. When you look at daily average high temperatures, okay, that's something that temperatures a day, and that information is tracked, and so you can see how temperatures change over time. So we're given a table here listing the number of robberies in the thousands and burglaries in the millions in the United States through the years 2009 and through 2019. And we want to do a time series chart based on that information. The x-axis always represents your time, okay? Time series data, your horizontal axis always represents your time intervals. and then your vertical axis represents whatever else that you're looking at. So if we want to describe the number of burglaries, we're just going to look at the burglaries column. We could also plot robberies, but because they're in different scales, it's not going to be quite right. But you often will see time series data, multiple things plotted along the same axis so you can see how each one changes over time. You can also compare the changes over time. A lot of times when you're doing things like stock market analysis, you can look at multiple companies and their performance over time and see how each company is doing and compare one company to another. So you can plot multiple values, multiple lines on a time series chart, depending on what it is you're trying to analyze. Okay? So our horizontal axis will be time, so we need to start with what year? 2009, and we need to go up until, I abbreviate that to 09, to 19. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so each dot will line up with the year based on the number of burglaries. All right, and looking at our scale, we have everything between, looks like 1.12 million to 2.2. So let's do a scale of 0.5 million. 0.5, then 1, 1.5, 2 million, and 2.5 million. So our vertical axis represents burglaries in millions. And our horizontal axis represents years, 2000s. Okay, so we have years in the 2000s, and then our vertical axis is the number of burglaries. So starting with our first 2009, where am I going to put that first dot? Okay, a little bit above 2.0. Maybe a little closer to the middle-ish. Right about there. All right, and the next one? A little bit below, and then the next one? A little bit above that one. Okay? Keep going.
A little bit below.
A little bit below 2 for 13, right? Yep, 13. A little bit below 2.
More below that.
Well put.
Below
Below that. Below that.
So should be pretty easy to pick up on what our trend was. So what was happening over time? Was it always decreasing? No. So when did it start decreasing?
2000.
So around 2011 is when it started to go down. So it was pretty consistent. Actually, I would say up until about 2012. It was pretty consistent as far as the number of burglaries went. And then after 2012, it started to go down. We can also look at areas where there was the least amount of change or the greatest amount of change by looking at the slope between points. The smaller or shallower the slope between a point, the less change there was from year to year. The steeper the slope from one point to the next, the more change there was from year to year. Okay, either going up or going down. Okay, so time series data has a lot of different ways that we can look at that as well. All right, so we've covered a lot of different ways to display data, qualitative versus quantitative. I want you to get used to recognizing what types of displays are better for different groups of data. Okay? If we have qualitative data, we're limited in how we can graph it. Pareto charts, pie charts. Quantitative data gives us more options. If we have time series data versus paired data, if our data sets are really spread out versus really clustered together, there are different displays that work better. So that's something that you need to kind of keep in the back of your mind while you're looking at and while you're graphing and analyzing the different charts that you're going to do. Okay? Questions, comments, concerns, queries, conundrums. Hope